Hello everyone, we are again back to our regular class on the Laplace transformation, and today's class happens to be lecture number 9 in this particular series, and you should refresh your memory on what happened in the last class so that it be quite easy and comfortable to deal with the topics that we are going to discuss. And in particular, we have completed the solution to this particular problem in the last class. The main thing that I would like to tell here is that we have a division by t here, and we also have a plan to get the solution to this problem where there is a division by t. So there is a function of t, and then 1 over t is present in these two systems, and then we are asking the question how to go about in evaluating either an integral like that or Laplace transformation of the function which contains an 1 over t function, 1 divided by t. So that was our objective in the last class, and there are two ways of dealing. The one method is for the integration, and the other method is for L is there here, so for the Laplace transformation. So that's what the topic that we were discussing in the last class, and we have completed this, and we are now on the way to get the solution to this first example. Now before we enter into the details, you have to understand what is the idea behind this calculation. We have some function. First of all, you remember that we need one function of t which is represented by f of t, and that is multiplied by t. Otherwise you can have a function of t which is multiplied by 1 over t. So multiplication by 1 over t is same as the division by t. So that is what you are having here. You have 1 over t getting multiplied, okay, to the function sine of bt. So this is the overall idea. You will be having sometimes multiplication by t or sometimes division by t. You can have t square, for example, here also t square, t cube here, t cube here. Okay, so those things are possible, and then you can always do it by repeatedly applying this technique. Okay, if you apply the technique once, you will be getting the solution for t multiplication. If you repeat it for 2 times, you will be getting t square multiplied by f of t and so on. So that is the overall idea, and we are going to discuss these two things together. In fact, you can ask the question, we have only multiplication by 1 over t. So this is the current situation for solving our problem. So the question that you will be asking is, why are we going to discuss t into f of t, which is not there in the given problem. So the point to be noted is that our aim here is to not solve a single problem like that. Okay, our problem is that you must know how to deal or how to go about when you are given some question, okay, in the examination. So in the examination, we do not know whether 1 by t will come or multiplication by t will come. So you must be able to deal with both the situations, and there is a relation between these two. So that is why I am clubbing these two things together. And first of all, we will see the first one in the beginning, that means multiplication by t, and then we will come back to this 1 over t. Okay, so first one we are going to do is multiplication by t. The second one would be 1 over t. So let me erase the second one now. So we are going to ask the question how to calculate the Laplace transform of t multiplied by some function f of t. So this is our objective, and the solution is quite simple and straightforward. So we can now see how to deal about. You directly write down the definition for the Laplace transformation, which is integral 0 to infinity given function. So given function is t times f of t. So that's your given function. Then you have to multiply by e to the power of minus st for the purpose of doing the transformation, and then the integration is with respect to the t variable. That's all about it. And then you are going to rearrange and then write down, and that's the answer. So the question is, how are you going to rewrite? So here you can see that there are two functions are there. One is t here and e to the power minus st. So these two things we are trying to combine together. That means let me write down this f of t separately. Then let me combine these two things, which means t times e to the power of minus st. Like this you can write down, and you can ask the question, what is the reason behind that? So the idea is that why do you want to write like that is, you can generate this function. That means a t is coming here and then there is a t here. So exactly what I am trying to say is, if I am going to have e to the power of minus 2t, and if I am going to differentiate this with respect to t, for example, how much you will get? So you will be getting e to the power of minus 2t multiplied by minus 2. Isn't it? So you can get a minus 2 there. You can also differentiate by another variable if this were another variable. For example, see here I am having 2 here. Instead of 2, you can ask the question e to the power of minus st. If I do that, e to the power of minus st, because there is a t here, I have to write down minus s. So that means you can get this variable s here. You can also get the variable t here by differentiating in a different style. For example, if I differentiate the same function with respect to this, with respect to s here, that is t here, then I will be getting e to the power of minus st into, now I will be getting minus t. So the point is that you can get a t here or you can get a s there depending upon what you differentiate. So now we are asking the question t multiplied by, so there is a t here, then there is a multiplication. So t multiplied by that is what is there here. So therefore what you understand, for that minus is there, you can always put the minus here at the beginning. So this is nothing but the derivative with respect to the s. So that's what we understand. So therefore what happens is we can write down integral 0 to infinity. This f of t is as such, we don't disturb it. This is nothing but the differentiation with respect to s. This one, this multiplied by that is nothing but the differentiation with respect to s of the function e to the power of minus st, and that's all. Now t is taken care, t has been taken care by this derivative, but then there is a minus sign there, therefore you put the minus sign here by writing minus 1 multiplied by, and that's all, multiplied by dt. So essentially what happened is that the multiplication by t has been absorbed. Okay, the absorbed means the t multiplication by t has disappeared. So now you see that the multiplication by t has disappeared in this equation. That is the purpose of doing this. And now comes the next important idea, that the derivative here is with respect to the s, whereas the integration, here we have the integration, is with respect to the t here. Therefore I have to say that this is t equal to 0 to t equal to infinity. So integration is with respect to t, differentiation is with respect to s. So you have the variable s here and you have the variable t here. These two quantities are independent variables. Independent variable. What do you mean by independent variable is, if anything happens to the t variable, nothing will happen to the s variable. That means s variable will remain as its original value. Similarly, when anything happens to the s variable, nothing will happen to the t. They are independent of each other. When they are independent of each other, now you are asking the question, I am differentiating with respect to s, integrating with respect to t, then it doesn't matter whether you want to do the differentiation first or the integration first. Okay, is that idea is clear? The idea is clear because one is with respect to s, the another one is with respect to t. Because they are independent of each other, I can perform the first operation for t and then the operation for s. Otherwise, I can do the operation first for s, then for t. In any order you can do, it doesn't matter because the two variables are independent of each other. So because of that reason, what happens is we can now bring this differential operator later. Later means you bring it to the beginning and then put the integral operator there, which means we are actually swapping the differential and integral operators, and then this becomes minus 1 multiple. Of course this minus 1 you just keep it here. Let me bring this differential operator like this, d by ds of the integral. So now I can write down the integral t equal to 0 to infinity of the remaining function. I mean whatever function that you have, f of t e to the power of minus st dt. So this step is very important, and what is happening here you can easily see. You can ask the question, there are you see this f of t which is there here, you can bring this inside without affecting anything. You can bring the entire f of t inside this and nothing will happen to the equation. The reason is the differentiation is with respect to s here, whereas this function is with respect to time. That means this is a function of t. This is differentiation is with respect to s. Therefore, whether you keep the f of t inside this bracket or outside this bracket doesn't matter. So therefore, we are bringing this inside and then putting this differential operator outside and then integral operator inside. So it is essentially nothing but simply rearranging the order, and nothing happens because of the reason that the two variables s and t are independent of each other. Where are s and t? That is there here, s and t. Okay, so that s and t is a part of the definition. S and t is part of the definition of the Laplace transformation. So this is the basic reason for this rearrangement, and this rearrangement helps you to get the answer quickly. That's all. So fundamental concept is this, and now we can rewrite this expression and then we get the answer. So let us rewrite that. So the last step we have, remember this last step we are going to write down now. So finally what we have is this expression, the Laplace transformation of t multiplied by f of t is, what we have is minus 1 times the differentiation with respect to s of the function. So if you want to, can you put a bracket optionally? For example, let me put a bracket like that. So the quantity inside that bracket, the quantity inside this bracket is nothing but the Laplace transformation of the function f of t, because this is nothing but the original definition of the Laplace transformation of the function f of t. Therefore I can now write down that this is nothing but the Laplace transformation of the function f of t. So this is the final result. So how do you understand this is that if you want to find out the Laplace transformation of t multiplied by f of t, then what all you have to do is you have to find out only the Laplace transformation of f of t, which means the multiplication factor is something that you don't have to worry about. That's all about. That's what you are going to have here. The question is that calculate the Laplace transformation of sine of bt divided by t. So there is a multiplication by 1 over t. So this multiplication factor is not required to calculate the Laplace transformation of the fraction. That means, what does it mean? What does it mean is, for this question, if you know, you ask the question, do you know what is the Laplace transformation of sine bt? Do you know this? You ask the question. If you know the answer to this question, you also know answer to this question. That's all about it. The multiplication factor is not going to give any trouble in getting the solution. That's what is the ultimate meaning. So how do you know that is? How do you know that this factor doesn't disturb the calculation? You see here, the Laplace transformation of this product where you are getting multiplication by t is nothing but Laplace transformation of the function f of t. That means multiplication of t is disappeared. How it has disappeared is, it has come in a different form like derivative. So that means multiplication factor has disappeared, means not totally disappeared. It comes back in a different appearance, like it comes like a derivative with respect to the s. So which means that you simply find out the Laplace transformation and perform a differentiation. That is how you understand if there is a multiplication. That means if you have a question like find out the Laplace transformation of t times sine of bt, if that is a question that you have, then you calculate by deleting this t. You remove this t and then calculate its Laplace transform and then perform the differentiation d by ds. That is how you understand. So the idea is clear, right? So we are focusing on the idea rather than getting the solution to only one problem. Okay. If you get the solution to only one problem and close the video or the lecture, then when the next problem comes, you do not know how to think or how to go about. So the idea is now clear that the multiplication has been converted to, or the multiplication by t reappears in a different style like derivative. That's the conclusion. It's a very important conclusion. And as I already told you, you can repeatedly do the same calculation. By repeatedly, what I mean to say is that suppose if I, instead of having t multiplied by, I can also ask the question, what happens if I am multiplying by t square? So t square multiplied by f of t, what will happen? So that is a question that you can ask, and you'll have to perform the similar steps here. You know what is the similar steps here? It's only rearranging the terms and then bringing the differentiation in the beginning, putting the integration later, and doing these steps. You will be getting a similar answer here, where the second derivative will give you a power 2 here. Of course, there is a power 1 that you have. So you understand that that's a power 1 there. D by ds means first derivative, isn't it? D by ds means first derivative. So if there is a 2 here, you must have the second derivative. So we can write down like this, d square by ds square. So it is the second derivative of the function f of t. Now, of course, we can use both the symbols. We can also write down capital F of s. So what is capital F of s? Laplace transform of f of t. So whether you write this way or that way, both are same, but you should always remember that L of f of t is what is written as, so f of s. So that's what I am writing here. So essentially you will be having an equation that is like that. So this clearly indicates that you can also perform n number of differentiations on this operation. Therefore I can have nth power if it is multiplied by the function f of t, then the result will be given by minus 1 to the power n. So 1 means first derivative, second derivative. Now we are going to have nth derivative. So I will write d to the power n divided by ds to the power n of the function capital F of s. Capital F of s is nothing but Laplace transformation of f of t. So this is the result that you will be getting by repeated application of the multiplication factor. Okay, so this is mathematically you can write down like this for nth derivative, but for practical purpose you have to repeatedly do 1 time, 2 times, 3 times, etc. rather than directly you don't perform nth derivative. Okay, so if there is a multiplication by t cube here, for example, if there is a t cube here, what do you do? If there is a t cube, you have to perform 3 times differentiation of the answer to Laplace transformation of bt. That's all. Okay, so that's an idea. So the idea is now clear. What happens when there is a multiplication by t? So whatever you understood till now, so let us write down here. So what do you understand from here? All these things is multiplication. This is multiplication by the factor t. So you are going to multiplication by a factor, or I will say that t times f of t. F of t is multiplied by t. Of course, t to the power 1, t to the power 2, t to the power 3, etc. So that is what you are going to have. Now we are asking the question from here. We are now moving to another question. What happens if I am going to multiply it by 1 by t into f of t? So only t is changed to 1 by t. What is likely to be, or what do you believe, or what do you think will happen if t is replaced by 1 by t? That's what you are thinking. So you can think about what can happen here. When t is multiplied, I am performing differentiation. So like this, you ask the question. When t is multiplied by f of t, what is happening is derivative with respect to s comes into picture. So you ask the question, what happens when 1 by t is multiplied by f of t? Then most probable answer is that what is the inverse operation for the d by ds integration, right? Inverse operation for the differentiation is integration. Therefore, when t becomes the inverse, that is 1 by t, d by ds becomes inverse operation. That means integration. So we believe that some integration should be here on the right hand side. That is what we expect. But however, we have to exactly work out and then write down the result. But our expectation is that we are expecting the answer or the solution to be like one integral should be there in the answer. That's what we are expecting. Let us now try and then see what happens when we do the 1 by t. So this is the part 1. Part 1 is completed where we have multiplication by t. So that's over. Let us now come to this 1 by t. Okay, so I will erase this.